Hello. I hope you're having a good day. And just have a little bit of bad news. I hope it doesn't bum you guys out. This is the last section in this chapter. I know. Try not to cry. Very sad. But we'll move on to fun things in the next chapter. Don't worry. But I know it's coming as a shock and you're probably very sad right now. Just kidding. Probably not. But what are we talking about here? Remember in the last section we talked about inequalities. We solved them and we learned how to graph them and put them in interval notation. So now we're going to put that to use. Probably one thing you were thinking, or now you're thinking it, is what the heck kind of use does that have? How often would you really need to solve an inequality in real life? Well, the answer is not too often. You don't see that too often, but you'll see in these word problems, applications. Sorry. People don't like word problems. But when you see the word applications, you know what that means. It means you're looking at word problems. But yeah, once you see these applications, you'll say, oh, okay, I guess I could see where you use solving inequalities in real life. That kind of makes sense. But the language is kind of tough. If they say it in English words, sometimes it's kind of tough to translate that to an inequality that you have to solve. So let's see. And there's not really a set way to go about it. It's just like with the word problem section, it's just more, I don't know, just the more of them you do, the better you get. And the more times you've seen the language, the more it's easy to recognize it. So how about in this first example, it's just kind of trying to translate a very simple inequality to a word in words to actual inequality. So let's see, in part A they say a number, and when there's some unknown thing, a number, we're going to call that a variable. That's kind of open-ended. I can call it X, you can call it Y or Z or A or B or C, whatever your favorite letter is. Doesn't really matter. Okay, so the number, it's greater than or equal to, all right. I think there's not really a mystery there. As long as you know how to write that, which direction that's facing. Greater than or equal to what? Okay, 4. That's not so bad, huh? Okay. So the best problems are when they give it to you very directly like that. Greater than or equal to. But there are some, like part B here, they're a little less clear. So what are they talking about? They have a very interesting concept here. The age of the Mayan altar. Wow. I want to know more about this, but unfortunately they don't tell us more. And we don't know what that is. The age of the Mayan altar, we don't know it, but it exceeds 1,200 years. So okay, since we don't know it, I'm going to call it X. The age of the Mayan altar, whatever that is, X. Exceeds, okay. Exceeds, is that usually you're greater than or you're less than something? I think if you exceed, you're greater than, right? If the age of the Mayan altar it exceeds 1,200, I think they mean it's more than 1,200 years old or greater than 1,200 years old. And, since you're just trying to translate it into math, you don't need to use the word years. That's just kind of giving you context, what this inequality is talking about. So I think that one looks good. Okay. Let's see, the next one. The cost of production cannot exceed. Ooh, that's kind of interesting. Well, I guess in this one, the cost of production, that's the thing we don't know. I'll call it X. It cannot exceed, I have to think about that, 12,500. Okay, so that, for some reason money makes it make sense more to me. So if the cost of something cannot exceed 12,500, that means I think it has to be less than, right? Or do you think I could say equal to? Like, let's say your mom said, all right, you can buy this, I don't know. I guess it depends what you're into, but you can buy this video game or you can buy this dress or these shoes as long as the cost isn't more than 12,500. That'd be an expensive dress. Let's pretend, though. I guess if she says, as long as the cost isn't more than, it sounds like as long as it's less than or equal to, I feel like it's probably okay, right? The production cost can't exceed 12,500, but it's okay to be equal to it, as long as it doesn't go over. I think that's the feeling I get. So it's tough. A lot of times they give you English words like that, cannot exceed, and you have to think about, wait, would that be less than? Even if you get the direction of the inequality correctly, less than or greater than, it's hard to know, is it or equal to? You just kind of got to put yourself in that position or that situation and think, would equal to be okay here or not? It's kind of tricky. Now, let's try the last one, and then I think if we can do that one, we can probably jump into an actual problem where we set up an inequality to solve. So, okay, last one, Ireland gets between 1,100 and 1,600 hours of sunshine each year. Okay. This one's kind of tricky, but it's important. So let's see. I guess the amount of sunshine, hours of sunshine, that's probably what we don't know, right? I don't know how many hours of sunshine they got. Let's call it X. So it's between 1,100 and 1,600. Since there's two numbers, if you want, you can set up two inequalities. Well, if it's between 1,100 and 1,600, I guess what I'm thinking is it's got to be greater than 1,100, but less than 1,600, you know? It's got to be in between the two. But now I ask myself, can it be or equal to, do you think? Do you think X could be equal to 1,100 or equal to 1,600? See the way they phrased it. Ireland gets between. That's kind of tricky, huh? I think the word between makes me think probably not equal to either. It's somewhere in between them, not one or the other. So this one, you can write it as a set of two inequalities like we did. But just so you know, you don't have to memorize this. It's just good to have seen this. You'll probably see in your next math class more of this. If one number is always between two numbers, like our X has to be between 1,100 and 1,600, you can write that in what we call a compound inequality. 1,100 less than X less than 1,600. So that's just kind of something to have seen before. You know, just having seen it will make it less shocking when you see it maybe next semester in your next math class. But don't worry about that too much. It's just kind of interesting, or it might be easier since you've seen it before. But if you just write it as two inequalities, I'm fine with that. That's no big deal to me. But if you've seen this, let's say you read the book or you're looking through the homework and they have something like this where they have X in between two guys. That's kind of what you would think it would be. It looks like, oh, look at X is between 1,100 and 1,600. That's exactly the words they used. X is trapped between 1,100, you know. So anyway, that one, it's good to have seen it, but don't worry about it too much. All right, I think we've got some good practice in. Let's try to see if we can solve one of these. Let's try example 2 here. So, okay, it's saying RJ's Plumbing and Heating, they charge $55, okay, plus $40 per hour for emergency service. Okay, sounds good. Gary was billed over $150. Just right away I was thinking over, that probably means greater than, right? Over, yeah, just anyway, thinking ahead. Over $150 for an emergency call. How long was RJ there? Ooh. So I gotta think about this. Just the basics is his bill was over $150, so I'm thinking greater than. I think that sounds right. His bill was over 150, or it's greater than. All right, but I got to think about the word bill. I'm not supposed to see words in math, right? So that's probably got to be replaced with some kind of algebraic expression. So maybe if you're ever stuck and you say, well, I don't know what to write, what kind of algebraic expression am I supposed to write? Think about what they're asking for. They're saying, how long was RJ there? I guess that's the number of hours, right? So let's say X is the number of hours. That might kind of help me write out what the bill is. So let's see, they said that he's going to charge $55. So that's already part of your bill. You're going to pay $55, it sounds like, no matter how many hours he was there. Plus $40 per hour. Okay, so let's say X is the number of hours. Or how about, let's make it specific. What if he was there for 3 hours? So if RJ's heating and plumbing was there for 3 hours, you would pay 40 times the number of hours, 3. 40 times 3, that's 120. But I made up 3 in my head. I just thought that would make it easier. And since we don't know the number of hours, it's just 40 times however many hours he was there, X. So hopefully that makes some sense. Yeah, because the number of hours he was there times 40, since that's the hourly rate, plus he's going to charge $55 no matter what. They want that to be greater than 150. All right, I think we got it down to an inequality now. All right, let's solve this guy. I'm going to subtract 55. That'll isolate X, or get us closer to isolating X. 40X. I don't need to flip the inequality. That'd be 95. Okay. Let me divide by 40, and then we'll have X all by itself. And I'm done solving for x, and I noticed I never had to multiply or divide by a negative number, right? So I never have to flip the inequality. Let me see, I gotta think about this. What's 40 into 95? Ugh. Well, 40 into 95, I think it can only go in twice. With 15 left over, let me bring down a 0 here. 40 into 150 is 3. 120 left, that's 30. Let's see, if I bring down another 0. So far I got 2.3. How far am I going to have to go here? 40 into 300, that's 7? Yeah, 7. 280. 300 minus 280 is 20. Oh, okay, here we go. 40 into 200 is 5. So it's 2.375. That's the guy. So it looks like RJ's heating and plumbing was there for at least 2.375 hours. And the good thing is in this section, if in the last section you got kind of tired of graphing the inequality and then writing your answer in interval notation, in this section they don't really care about that so much. Since it's word problems, remember how we like to write word problems, our answers in words. So I'm going to say RJ was there for... It's kind of, the language is up to you, but the language I think of is he was there for more than 2.375 hours. Or you could say for greater than, that kind of sounds strange, for greater than 2.375 hours, but you know, whatever you want to write. That's the good news in this section, if there is any good news, is that you don't have to graph the inequality, because it's a real life situation, you know, you wouldn't really need to in real life. And then you don't have to write it in interval notation. Interval notation is more purely a math thing that's useful for other math things. But this is real life situation, so I don't think it's really that useful. Okay. That was fun. Let's try this next one. Example 3 here. We got Rod's quiz... I can't even speak. Rod's quiz grades are 73%. Or, they didn't say percent, I'm imagining. 73, 75, 89, and 91. What scores on a 5th quiz will make the average quiz grade at least 85? Ooh. I could see this being interesting to students, right? If you say, all right, I got 1 exam left in my class, or I got 1 quiz left. And I want to make sure I pass this class, or I want to make sure I get at least a B. This might be something you want to solve in real life, so this is pretty useful, I think. Let's see, okay. The good thing, or the main thing to keep in mind is how do you average things? If you remember, you average things by saying, okay, you add them all together, so 73 plus 75 plus 89 plus 91, but it sounds like there's going to be a 5th quiz, so maybe I'll call that X. You know, I don't really know what his score is going to be, so I'll just call it X. But to average things, remember you add them together, and then you divide by the number of items you're adding. Then divide by the number of things you're adding. So that, they didn't really give that to us in this problem, but I guess they're assuming we know how to average things, but I don't know, not everyone remembers that. Alright, so you say, alright, how many things are there? 1, 2, 3, 4, and then the 5th quiz, so 5. Once we add them together, we're going to divide them all by 5. That would be the average. Alright, that was pretty good. So what do they say about the average? They want the average to be at least 85. Let me see, I'm going to write this over again here. Oh, why did I put a 5 there? 73, 75, 89, 91, X. All over 5, something compared to 85, because they said they want that to be at least 85. At least, okay. What does that mean? Greater than, less than? I think it's going to be a greater than, right? I want my grade to be at least 85, so it's greater than, but I think, or equal to, right? When someone says, I want at least 85, it kind of gives me the impression that they're okay with 85. They'd prefer more probably, but 85 is okay. Alright, I think this is what we're solving here. And it looks complicated, but it's going to get a lot less complicated once I add all these numbers here together, right? There's 4 numbers here that I can add. And don't get mad at me, but I can't do that in my head, you guys. I'm going to go off over here and do it. Let me see, add those guys. 10, that's 18. 18, 19, 25. I think 32. Let me try that again just to be safe. 10, 18, 19, 25. Yeah, so 328, I think that's what that is. Those four numbers added together. But of course, there's an x up there in the numerator with that. That's over 5. Greater than or equal to 85. Okay, if I want to solve this, remember how we said if you're solving for a variable, you want to kind of get rid of things the further they are from x. So I know I need to get rid of this 328 and the 5 that's in the denominator, but it looks like the 5 is the furthest thing from x. So I'm going to get rid of that guy, and since it's dividing, I'm going to do the opposite and multiply. Multiply both sides by 5. So 5 times that fraction, 5 times the 85 on the other side. And I can tell that was a good idea because if I put this 5 over 1, the 5's cancel on the diagonal. So that was a good idea. That does get rid of that 5. And now all that's left is the numerator, 328 plus x greater than or equal to, the inequality doesn't flip backwards because I didn't multiply or divide by a negative number. 5 times 85, oh geez, here we go. What's that? 25, 425. Alright, we're almost there. Let me move that 328 over here. 328. Let's see, 425 subtract 328 is 97, I think? Yeah, I think so. Okay. And it's a good sign that sounds like a score on a quiz, 97, you know? That's a pretty high score, but I guess he kind of got some low scores, so to bring his average up to an 85, it has to be high. So I'm trying to sum this up in a sentence, Rod, he would need, I guess, well, how would you say that? A greater than or equal to, you could even say that if you want, greater than or equal to a 97. You could say at least, that's kind of a nice way to say it. But don't worry, you can always say the exact words. Rod would need greater than or equal to 97. That's fine. It just sounds like more conversational when I say Rod would need at least yada yada yada. I guess I should say on quiz 5. That way everybody knows what I'm talking about. Like, he would need a 97 on what? His average or his final exam? No, on his quiz. Alright. That one was kind of tricky, huh? So it's mainly about averaging. So if you see an average problem, just remember you gotta add all the scores together, even if there's one that you don't know, and then divide it by the number of things you're adding, etc., etc. Okay. So example 4, let's see what this guy's all about. It's talking about a rectangle, so I think, kind of like in a previous section, I'm going to draw a picture, because I think that kind of helps me to label the sides and all that stuff. So it says the perimeter of a rectangular sign is to not exceed 50 feet. Let me see. I'm going to write that out, kind of brainstorm. Perimeter should not exceed 50. What does that mean? Should be greater or less than? I think should not exceed means less than, huh? So it shouldn't be bigger than 50 feet. But I think it sounds like they're okay with equal to. Like, as long as it's not over 50 feet, it's okay. I mean, 50 is fine, less than 50 is fine. The perimeter should be less than or equal to, yeah, I think that sounds good, okay. And then the next sentence, they're saying what? The length is to be twice the width. So, I don't know, it doesn't really matter which one's width. I might say this is the width here. So then the length, this distance, should be twice the width. Let's say the width is x. Or you could just call it w for width if you want. So if the width is x, then the length, double that would be 2 times x. Because how do you double something? You just multiply it by 2. Alright, I think, you know, if you want, that rectangle looks kind of complicated. If you want to draw it in a simpler version, you could just say, alright, this is 2x and this is x. Because I kind of wrote a lot on there, which kind of makes it look complicated. But since we're talking about perimeter here, perimeter, remember, is the distance all the way around. So since I know the length of one side here, x, and a second side here, 2x, I would need to know the lengths of the other sides. But thankfully, in a rectangle, 2 sides that are opposite of each other are the same length. So this would be length x, and this side would be a length 2x. Since, yeah, the sides that are opposite of each other should be exactly the same. Alright, so perimeter, remember that means you're adding all the 4 sides. 4 sides. And whatever that ends up being should be less than or equal to 50. And the four sides are, doesn't matter which order you put them in. I see one side here is x, the next side is 2x, the third side is x, and the last side I haven't listed yet was another 2x. Man, don't worry about putting those in that same order. As long as the four of them are there, we're going to get the same answer. Alright, now I think we're ready to combine. These are all like terms. Every single term on the left side is a like term. X plus 2x is 3x, plus another x is 4x, plus 2x, that makes 6x total. And that should be less than or equal to 50. Alright. Now to solve this, the last step would just be to get rid of that 6. Or the only step, actually, huh? Divide by the 6. Is 6 going to 50 evenly? No, huh? Let me try to do this off to the side here. 6 into 50. 6 can go into 50 8 times? 8 times 6 is 48. Let's see, 2's left over. Let me add another 0 here. Oops. Let's see, bring down the 0. 6 into 20 is 3. 6 times 3 is 18. Bring down another. It looks like we're going to keep getting 8.3333, you know, like that. So x has to be less than or equal to 8.3 bar over it. But I already forgot what we were talking about here. What widths will meet this condition? Okay, was x the width? Yeah, it was. Okay, up here we labeled width was x. So we found what we need. I'm just going to try to sum it up in words. So, there's a lot of ways to phrase it. I'm going to say, as long as the width is less than or equal to 8.3 with the bar, the sign, I don't know, is good to go. I don't know. That's a little colorful language, huh, for a math class, but I think people know what I mean by that. You can put that sign up as long as the width is less than 8.3 with the bar. Sounds good to me. Alright, you guys. This is a lot of fun. I'm kind of sad there's only 2 problems left in this section. In this whole chapter. Don't cry. It's okay. Be strong, you guys. Be strong. What do we have? Another one. These are so much fun. Insurance companies. You had me at insurance company. I mean, it doesn't get more interesting than that, am I right? Just kidding. Alright, most insurance companies will replace a vehicle if an estimated repair exceeds 80% of the Blue Book value. Okay, that makes sense. That's what they say, right? If you have to repair your car, especially if you have an older car, and the repair costs almost as much as the car is even worth, it's probably not worth getting it repaired. You might as well sell it or just give it away or whatever. So that makes sense. Okay. Michelle's insurance paid $8,500 for repairs to her Subaru after an accident. What can be concluded about the Blue Book value of the car? Alright, this one you have to use a little logic because they don't really spell it out for you too much. But you notice that it said here, Michelle's insurance company paid $8,500 for repairs. So since they paid for repairs, that must mean that the repairs must not have exceeded 80% of the Blue Book value. Alright, so that might be something I want to keep in mind. So the repair cost must have been, what, less than or equal to 80% of the value of the car. I guess. Because when they say the repair can't exceed, or no, if the repair exceeds, then da-da-da. But I guess the repair was less than 80% of the Blue Book value. Yeah, that makes sense. Okay. But what about the repair? Well, actually, I was thinking, how am I going to do this, huh? Let me think about how to set this up. Let me think. The first thing is, if you ever get stuck on these problems, think to yourself, what am I going to let the variable be? Or what are they asking for? What can be concluded about what? The Blue Book value. All right, I'm going to say x is the Blue Book value. All right, I think that'll help a lot. All right, let's see. So this guy, what is the repair cost? You know what? That's exactly what they gave me, right? Their insurance company paid $8,500 for repairs. Okay then. That was easy. Alright, I like that. I think it's the right side of this inequality I gotta think about. 80% of the blue book value. Okay, I think I'm gonna write another kind of brainstorming thing. 80% of the blue book value we called X. So on the right side, I gotta write something that's 80% of X. And actually, you know what'll help us out with this problem is, remember in that section where we were solving percent problems, we said that the word of is keyword for multiply. And remember that when you see a percent, you want to change it to decimal form. So we have 0.80, that's the decimal form of the percent. Of means multiply, remember that? Because that is how you find 80% of something, right? If someone said, what's 80% of bleh? You would take 0.8 or 0.80 and multiply it by the number. Okay, see, that section helped, right? It helped us set up this equation here. And I don't really need that multiplication symbol. That's just kind of there to confuse me, sort of. Alright, there's our equation we have to solve. Now all I have to do is isolate x. And the way to do that is to get rid of this 0.80. I'm going to divide both sides by it. There it is. Okay. So x is by itself, and I do not need to flip the inequality because I never multiplied or divided by a negative. But it comes down to me dividing 0.80 into 8,500. So I better try that. And we've seen this before. It's not very fun to divide a decimal into a whole number. So I think what I'm going to try to do is see how many times I'd have to move this decimal over to make it 0.80 a whole number. It's kind of deceptive because it looks like I have to move it twice, but if you think about it, what if I move it once? I just move the decimal to the right of the 8. And that's 8.0, which is 8. So really, I only need to move the decimal once. I'm going to move both decimals one time. Twice would work, but it's kind of overkill. It's kind of making the problem harder than it would have to be. I want to make this guy an 8, and this would become 8500 and one more 0 since I moved the decimal over. Whatever that is, that's what x will have to be. Well, that'll be less than or equal to x. Okay, let's see. Let's try to start dividing this guy. 8 can go into 8 once. If I bring down the 5, 8 cannot go into 5. It goes in 0 times. 0 times 8 is 0. If I subtract, I get 5. Now if I bring down the 0, 8 goes into 50 6 times, right? Yeah, 6 times 8 is 48. If I subtract those guys, I get 2. If I bring down 0, 8 into 20 is 2. 2 times 8 is 16. If I subtract those, I get a 4. Ooh, and if I bring down this 0, 8 goes into 40 evenly. Yay! No decimals necessary. Yay! Okay. So it looks like the number we got was 10,625, less than or equal to x. But remember in the last section we said it's always better to have your variable on the left, because that's kind of confusing. It's hard to interpret when your variable's on the right. So I'm going to switch the variable and the number. But if you remember, if you switch the variable and the number, you have to flip the inequality. It's like, imagine that guy's mirror image. So x has to be greater than or equal to 10,625. But since this is a word problem, I'm going to want to write this as a sentence. And I already forgot what x stood for. Let me go back to the beginning. I wrote here, it's a good thing I wrote it because I forgot. X is the blue book value. Okay, so I think I can say the blue book value of this person's car. What was her name? Michelle. Michelle's car, whatever, was greater than or equal to that number, 10,625. Well, I guess a more interesting way to say it would have been the blue book value of Michelle's car was at least 10,000. Yeah, that would have been more interesting, but greater than or equal to works. It's not pretty, but it'll get the job done. Whew. That one seemed tricky, huh? But I think most of the work was in this division here. That was the kind of painful part. Okay, last one. Try not to be too sad, guys. So this last example, example 6, it says, Liam has budgeted 60 cents. $60 per month. That'd be a cheap phone plan, huh? $60 per month for his cell phone. Okay, for his service, he pays a monthly fee of $39.95. Alright, so that just must be the flat fee no matter how many minutes he's using, how many texts, all that stuff. He pays a flat fee of $39.95, plus he pays taxes of $6.65. Okay, plus he pays 10 cents for every text message that he sends or receives. Whew. Wow, alright. They want to know how many text messages can he send or receive and not exceed his budget. Okay, interesting. So I guess he does not want to exceed his budget. So you want what? Amount, let's see, the cost of his phone to be something compared to 60, because that's his budget, right? He said he can't spend more than 60. Does it sound like, I think less than, huh? You don't want your phone to cost more than 60. You think or equal to? I'd say or equal to, because he did say he budgeted $60, so he has that set aside just in case it's going to cost that much. Okay. I just got to figure out how to interpret the cost of the phone in math terms. Well, it sounds like the cost of the phone is kind of broken up into 3 pieces. It's a flat fee of $39.95. He's paying that no matter what. Plus he's paying taxes no matter what, $6.65. That doesn't really depend on anything either. And then what is it? 10 cents for every text message he sends or receives. That's kind of tricky, so maybe for now I'll write the cost of his text. I don't know how much that is yet, but it's whatever his text costs. That's kind of tough to think about too, so I might want to say, I want to let X be the thing they're looking for. What are they looking for? They said, how many text messages can he send or receive? That's what I'll probably let X equal. X is the number of texts. I think I'll just keep in mind it's send and receive, you know, whatever. Alright, so if X is the number of texts that he sends or receives, how would you figure out how much it costs? Well, I guess if it costs him 10 cents per text, which is $0.10, right? That's 0.10 for every text, so it's 0.10 times the number of texts, which we called X. That's the cost of his text. So, you know, if let's say he sent 20 texts, sent or received 20 texts, that would be 0.10 times 20 would be how much he's paying. So I think that makes sense, and then I have to bring down these numbers because, you know, no matter what X is, no matter how many texts he's sending or receiving, he's definitely paying this flat fee and this tax here, unfortunately for him. So I think that's it, huh? It sounds like that's the cost of the phone. So these are like terms since they don't have a variable. I'm going to add those guys together. Ooh. I'm going to be careful on that one though. What's $39.95 plus $6.65? I feel like if I try to do that in my head, I'm going to make a mistake. That's 16, 9, 16. $46.60 I think is what those add up to. $46.60. Alright, plus that 0.10x. Less than or equal to 60. I could have, I guess, even before this point, I could have multiplied this entire inequality by 100, or even 10, I guess, if I want to move the decimal over. You want to do that? You don't have to, you could solve this. Well, yeah, I like to do that. I don't like decimals, it scares me. I think I'm going to take this equation, or this inequality, and multiply it. Let me think, do I really need to multiply by 100, or can I just multiply by 10? I think in this one I'm okay multiplying by 10, because that would move this guy's decimal to the right once, which would make it 466.0. That's just 466. That's a whole number. It would move this guy's decimal over once, which would make it 1.0. But 1.0 is 1. And it would make this guy a 600. So yeah, I think I'm good multiplying this whole thing by 10. That'll get rid of all the decimals. And you don't have to do that, I just think it's going to make it easier. Because I don't like dividing by decimals or subtracting or adding. If I don't have to, I'd rather not. Alright, so I'm going to multiply this guy by 10, this guy by 10, and this guy by 10, and then I think we're going to be doing well. So let's see. 46.60 times 10. We'll move the decimal once to the right. So it'll be 466.0, but like we said, that's just 466. So I don't really need to write the 0.0. And then 10 times 0.10, I'd move the decimal once to the right, and that would become 1.0, but 1.0 is just 1. That's it. And then less than or equal to, because I'm not multiplying or dividing by a negative number, 10 multiplied by 60 is 600. I'd have a 600 over there. And look at that. That's so much nicer. And this is, if I want, I can even write this as just x, right? 1 times any variable is just that variable. So this actually, I only need to do one step left. I just have to move that 466 over, and x will be all by itself. Not too bad, you guys. This is not too terrible. Okay, now that I move 466 over, x is by itself. Uh-oh, can I do this in my head? 134? I think? Let me see. Yeah, I think that's right. Alright. And I don't know about you guys, but after all that work on these problems, I always forget what I was doing. What was the whole point of that? What was x? Are we still talking about the Kelly Blue Book, or whatever, the Blue Book value of a car? I don't know. No, this one's talking about, remember above we outlined x is the number of texts that he's sending or receiving. So that means he has to send less than or equal to 134 texts. Okay. So what's his name? Wait, did they give us a name here? Oh yeah, Liam, that dude. That one dude, Liam. Liam must send less than or equal to, I know that's kind of awkward English language, but 134 texts. Ooh. I should say send or receive, huh? I forgot about that part. Send or receive less than or equal to that many texts this month or something like that, I guess. To stay within his budget. So I know that language is kind of boring, right? Liam must send or receive less than or equal to. I guess you could always say the number of texts. That's probably a nicer way to say it. The number of texts sent or received. I'm going to use their language against them. Must not exceed. Remember that? Right? 134. I like that even better. That's a winner right there, huh? That's not necessary. I mean, who's going to write this down? Okay. So those are pretty painful, but I think if it made some sort of sense, that's a good sign. And just, take your time on these problems. When you come across these in the homework, don't rush it. Don't feel like, oh, I should know exactly how to set this up as soon as I look at it. What's wrong with me? No, these are difficult. You just kind of got to brainstorm, and I guess don't be afraid of not knowing exactly what to do. There's no shame in that. It's just, actually, I think struggling with a problem makes you learn more than if you knew how to do it, exactly right the first time. So in a way, struggling with the problem is actually a good thing. But I guess that's it for this section. I'll see you again in the next section. Thanks for sticking with it, and don't worry, you'll do fine as long as you take your time, like I said. All right, talk to you later.